Okay, so number 9 on page 641. So in the diagram, it says, and I started this in the last video, it shows two pith balls, so they're little pieces of styrofoam, and they both have a mass of 1.5 grams. One ball is suspended by a thread, and the other is brought close. They repel each other, so they're charged the same, okay? And the question wants us to calculate the charge if this one, so it's hanging by a thread and we bring this one close, it repels it, so it swings up. So in the end, it's up here. The angle that the thread makes with the horizontal is 20 degrees, okay? And then it just stays here. It's suspended because of the repulsion. So it means all the forces are balanced on this pith ball. So if we take a look at this pith ball, what are the forces? Well, there's the FQ going this way. There's an FT going this way. There's an FG going down. Okay? And the forces are balanced, which means that if we do the sum of the forces in the x direction and in the y direction, they should both equal 0. So the FT has two components. It has an FTY going up, and it has an FTX going to the side. And if that's 20 degrees, this is 20 degrees. Okay, so you're just going to do sum of the forces like we have so many times this year. So if we do sum of the forces in the y, it has to be equal to 0. And so we'll have FTY minus FG equals 0. So FTY is the adjacent side. So this is FT cos theta, and that's going to equal mg. So that means FT will equal mg over cos theta. And you could actually find it here because you know m, you know g, and you know theta. I would probably instead carry it over to the x and do, because we're looking for q, I think, the charge, yeah. So I would go to sum of the forces in the x direction, and it's not moving in the x either, it's suspended, so that goes to 0. So it'll be FQ going one way and minus FTX acting the other way equals 0. So FQ is going to equal FT, and x is sine theta. So FQ is really K Q1 Q2 over r squared, and FT sine theta is really mg over cos theta times sine theta. So this will be kq squared over r squared, and this will be mg sine over cos is tan. And now you're solving for q, so multiply by r squared, divide by k. So q squared will equal r squared mg tan theta divided by k. So fill in your numbers. R, it said, was 2.6 centimeters. So 0.026, I'm just double checking. Yeah, it is 2.6 meters, and that gets squared. And the mass of the pith ball, they told us, was 1.5 grams. So 0.0015 kilograms. And yes, you do need to change them. G is 9.81 meters per second squared, tan of 20, and then that gets divided by 9 times 10 to the 9th Newton meters squared per coulomb. Sorry, still in the last unit, coulomb squared. Okay, so you type this in your calculator, and remember, you get, that's q squared, you need to take the square root. And so when you take the square root, I believe you get 2.006 times 10 to the negative 8 coulombs. Now it could be either both positive or both negative. Both positive or both negative, right? Because when you take the square root, you actually get a plus or a minus. But if the pith balls are repelling each other, it means they both have the same charge. So they could either be both positively charged or both negatively charged. And I'm just, yeah, it doesn't say that either way. So yeah, both positive or both negative. Okay? Makes sense? So it's really just sum of the forces. which you're actually really good at. So all should be okay. All right,